Hello all, and we are now on our third lesson of our electricity unit, and this lesson will focus on Ohm's Law and current electricity. So, current electricity, what I want you to think of is it's kind of like flowing water, and that's why I have a picture here, this little guy playing with a fire hose, okay? So if you will, this fire hose, if this valve was shut off and there was no water going through it, all right, we would have a bunch of stored energy here, a bunch of stored water pressure, right? Well, in the case of current electricity, this guy could be what we would call an EMF, okay? A store of electromotive force. And typically, in the stuff that we will be talking about, think of it more as a battery in electrical terms. All right, so when you open up the valve, you let all this water out, right? Then the amount of force the water pushes with is a force. Well, when we open up a switch to connect a full circuit from the battery, the amount of force, or the amount of the electrons that go out in a certain given time over a certain distance, is the electromotive force of that current electricity, okay? So think of it like flowing water in this water hose. There are some major players that we have to talk about when we talk about Ohm's law and current electricity. And these three are going to be voltage, current, and resistance. Okay? Voltage, again, is the force that pushes electrons. We also call that the EMF, or the electromotive force. Okay? And again, it's measured in volts. And the unit for volts is a capital V. Excuse me. All right, next player is current, represented by the unit symbol I. Okay, and again, that's because Latin has I for current, I believe, and that's why they're different letters. All right, so the speed of coulombs, again, remember coulombs is like a teaspoon, but coulombs of electrons, a whole bunch of electrons per second, and that is measured by amps. Okay, so current is the measure of the speed of the water flow, or in this case, the electricity flow or electron flow. All right, so voltage is the force, that's the punch. Current is the speed, or how fast the water is moving. Okay, so then the last player is resistance, and that is the ability of an object to slow down the flow of electrons. So the flow of water is slowed down by gravity, or hitting particularly like a wall, or let's say you're hitting this against a fence and there's some holes in the fence. Some of the water is going to get through, but some of it's going to get blocked. And the resistance in electricity would be things that you plug into your outlets. So resistance could be things like the microphone I'm using to talk to you right now, a light bulb, a fan, whatever. Things that you actually are plugging in that you need the electrons for. Okay, and they are measured in ohms, and that is represented, the unit for that is the Greek symbol omega. All right, for quizzes, working knowledge, tests, your life, you're going to need to know the units of this stuff. So voltage is a capital V, current is a capital A for the unit, talking about amps because it's measured in amps, and the resistance is ohms, which is represented by omega. Now, the symbols for these represented in Ohm's law is V equals I times R. Voltage equals current times resistance. And let's dive into that awesomeness, that awesome law that Georg Simon Ohm created. And Georg is correct. It's not George without the G. It's Georg. Okay? Born in Germany, or what is now Germany, would have been Bavaria back then. He was homeschooled. Spent most of his career as a high school teacher. Published his most important work in 1827, won the Copley Medal in 1841. The reason he did not win the Nobel Prize is because the Nobel Prize had not been invented yet. Okay? So things that we need to know about him, what he did. He created Ohm's Law. And what is Ohm's Law? That is this formula. V equals I times R. Volts equals current times resistance. In words, that means that voltage has a direct relationship with current. Voltage also has a direct relationship with resistance, but it has an inverse relationship between current and resistance. Okay, or there's an inverse relationship between current and resistance. So what does that mean? All right, so this is an important slide. We're going to be here a while, dive in. We're going to go through all these fun symbols here hopefully by the end of it, you will have a good understanding of inverse and direct relationships as well as Ohm's law, okay? Let's start with direct relationship. And what that means is, again, on a y-axis, you have increasing going up, and on x-axis, you have increasing going to the right. So as income goes up, as we go along the x-axis here, the amount of consumption, the amount of stuff that we buy also goes up. And that is represented by this line. So as one thing goes up, the other thing goes up, and it represents or ends up looking like this awesome diagonal line. All right, that's a direct relationship. So what does it mean when we talk about it in Ohm's law? Voltage has a direct relationship with current, okay? And if we look at the equation, we can look at it here. As we increase volts, does it not make sense that the current would go up? Because current times resistance equals voltage. So if the voltage goes up, the current has to go up. If we increase the current, the volts also has to go up. See how that works? And I'll show you an example. Let's say we start with 1 on each. 1 times 1 is 1. So we would have 1 across the board. 1 amps, 1 ohms, and 1 volt. Okay? Now let's say we increase the amount of current. Let's say we have 2. Here we have 1 ohm still. We have 2 amps. Okay? So now 2 times 1 is 2 volts. See how that went up? So when you increase current, you increase voltage. And the same exact thing would happen if you did it with resistance. All right? So if we start with 1 of each, again, 1 of each, we get 1 across the board, right? 1 times 1 is 1. If we increase the resistance to 2, we increase the resistance, our total voltage is now 2. 1 times 2 is 2. So if you increase resistance, you increase voltage. If you increase current, let's make that a 2. 2 times 2 is 4. You also increase voltage. And that's what it means to have a direct relationship. If you increase one, you're going to increase the other. So what does it mean to have an inverse relationship? And that is this guy here. That means if we increase the price, the number of people buying the tickets goes down. Okay? So that means as one thing goes up, the other thing goes down. That's an inverse relationship. And that means that, or that's what it means when it says that current, I, has an inverse relationship to R, resistance. And you can see that in these formulas. If I am looking for current, I have to change up this formula a little bit, all right? I have to have voltage over resistance. So that means if I start with, say I start with 1 on each, okay? I'm looking for I, and I have a 1 here and a 1 here, okay? That means 1 divided by 1 is a 1, all right? Now let's say I increase my resistance to 2, okay? Now I don't touch anything with voltage here because remember the inverse relationship is current and resistance. So if I increase my resistance to 2, 1 divided by 2 is what? It ain't 1, it's 0.5. Okay? See how if resistance goes up, my current goes down. Same thing holds true for resistance. If I start with 1 here, 1 divided by 1 gives me 1 ohm for the resistance. If I increase the current now to 3, 1 divided by 3 is 0.333, which is much smaller than the original one that we talked about with 1. All right? So that's where we get inverse relationship. As 1 is increased, in this case current, resistance is decreased. All right? Make sure you understand that. There's a reason I just spent 5 minutes talking about that particular issue. That is Ohm's law. That's what he did. He proved that if you increase current, you're increasing voltage. If you increase resistance, you're also increasing voltage. If, however, you're in the looking out or you're searching for current, then if you increase resistance, current goes down. And then vice versa, if you're looking for resistance and you increase the current, resistance goes down. And why am I showing you this picture with a triangle? It's another way to organize this formula. Just know that V equals, and then if they're next to each other, it's a multiplication, so I times R. If you're looking for I, you have V divided by R. If you're looking for R, you have V divided by I. Okay? And that's the way that this triangle works. You can memorize it any way you want. For me, I was very good at algebra, so V equals IR. Okay? That's what I'll start with. That's the formula we'll write down. And then if I need to find I know if I divide R by both sides, these R's cancel out, so then I equals V over R. Okay? That's algebra. Hopefully you know that. Hopefully that's not confusing. But if you want to just memorize the 3 different formulas versus how to manipulate the one, I don't care how you do it. Okay? So, whoops. All right, so that's why we love him. That's what he did. He created Ohm's Law. Ohm's Law is voltage equals current times resistance, and he determined this formula based off of these relationships. If I increase voltage, I increase current. If I increase voltage, I increase resistance. However, if I increase current, I decrease resistance, and vice versa. If I increase resistance, I decrease current. Inverse relationship. That's why we love Ohm. Fun facts on him. The unit of measurement for resistance is the ohm, and it's represented by the Greek omega because that's a cool way to write O. All right. He also has a lunar crater named after him. It's right there. Ooh. Now, here's the other main point that you will be using for the remainder of this semester. Not just this particular unit, but this semester. So commit these steps to memory. All 5 are vital. This is how we are going to grade your math problems going forward. Okay? There are 5 possible points for each math problem we do. So even if you get the wrong answer, but you did the other steps correctly, or some of the other steps, you will get partial credit. However, if you just write the right answer and you don't do the other steps, you will get fewer points for that. So if all you did was write the answer with the units, you get 1 point, which means you don't get these 4 points, and that would be bad. All right? So you have to do all 5 of these things for every math problem we do going forward. Step 1, write down all the numbers in the problem with formula abbreviations and units. So we're going to practice this, and I'll show you what that means. Make sure to include the unknown. All right, so that, let's say we have V equals I times R. I give you voltage as 5. I give you current as 2, and I want you to find the resistance. Okay, this is step 1. I write down what I've got in my problem, and I write down what I'm looking for, represent it with a question mark. Okay, now step 2, I write the formula without numbers. That's step 2. Okay, whichever formula I'm supposed to be using, that's what I write. I then fill in the numbers without units. So if I go back to my thing here, I got 5 volts, I equals 2 amps, and resistance equals, I don't know. Okay, so now I've step 1, step 2, step 3 is 5 equals 2 times R. I then work the problem, so step 4 equals R, and R, oops, get rid of that, don't need that. 4 is R equals 5 divided by 2, and that equals 2.5 ohms, and that is step 5. Okay? If I have all 5 of these things, I get all 5 points. If I have one of these things, I get 1 point. Make sense? All right, so let's try a real example here. A 12-volt battery has a light bulb attached. There is a current of 4 amps running through the circuit. What is the resistance of the light bulb? Incredibly similar to the steps we just did. Okay, the problem I just worked through. So step 1, I have to write down the stuff that is in my word problem with their abbreviations for the formula. So I have my first number here, 12 volts. So volts equals 12 volts. I go along, has a light bulb attached. There's a current of 4 amps. Current is I, 4 amps. Running through the circuit, what is the resistance of the light bulb? So resistance equals question mark. That is step 1. Step 2 says I need to write the formula without any numbers. So just the formula that I'm using. Volts equals I times R. Step 3 says put in the numbers. So 12 equals 4 times R. Step 4 says work the problem. Okay, R equals 12 divided by 4. And that equals 3 ohms. And that, my friends, is step 5. The correct answer. Okay? The correct answer must have the units, and that is the only time you place the unit, okay, beyond step 1. I, as a good practice, will always write the units in step 1 so that I keep them straight. Okay? Remember, I equals current, and that has a unit of A for amps. Okay? Resistance is an ohm. And volts is the easiest one. That's voltage. And that is represented with a capital V. Okay? So that is problem solving. You have several to work through. Good luck with it. And hopefully we will have great success with it coming. This is a very easy thing to start with. And we will have lots and lots of math throughout this semester. Your video secret number for the day is the brand number of 7. 7 is your video secret number for the day. All right, good luck with your homework, and I will see you guys in class.